Okay, so I'm going to be talking about 10-6, the distance formula. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And so the first problem is the distance between the coordinates 2, 1 and 5, 5. So I wrote down the formula just so I can help me remember. And so I plugged in the numbers, and I got 3 squared plus 4 squared. And that became 9 plus 16, which became the square root of 25, which is the perfect square of 5. So the distance between these two coordinates is 5. And for the second problem, I used the coordinates 3, negative 6 and 11, 9. So I wrote down the formula again to help me remember, and I plugged in the numbers and got 8 squared plus 15 squared, which became 64 plus 225, which became the square root of 289, which is a perfect square of 17. So the distance between these two coordinates is 17. And then for the third problem, I did the distance between a, b and b, a. And so I plugged in the variables just like numbers, and I flipped these two into a minus b so they could be the same quantity, and so I could add them together to get 2a minus b squared. And so this became root 2 times the absolute value of a minus b squared, and its absolute value, because it came out of a square root, and everything that comes out of a square root must be positive. And then for the last problem, I did the distance between the coordinates 4a, b and 2a, negative 3b. So I wrote down the formula again to help me remember, and I plugged the variables in just like numbers. And so this simplified down to negative 2a squared, and then this simplified down to negative 4b squared. And so it became the square root of 4a squared plus 16b squared. And so I could take a GCF out of 4, and so it became 4 times a squared plus 4b squared, and because 4 is a perfect square, I took out the 2 out of the square root, so it became the distance as 2 times root a squared plus 4b squared.